Hey everyone. We're just going to take a few minutes. We've had a few messages from people saying that they're not going to be able to make it on time. So I've set up a little countdown to let you know when we're going to start. While we're waiting for those people to turn up, marketing have asked me to just let you know some sort of housekeeping tips. Please do ask questions. We're going to have a Q&A at the end. I'll take some of the questions that we get asked. Apologies if we don't get to them all. We do get a lot of questions on these webinars, but what we'll do is we'll make sure that Alice and Michelle and the rest of the team will get back to you with answers in the next few days. If you do want to get in contact with us, either drop us a line through the chat console and we'll make sure we get back to you, or feel free to go to our website, starleaf.com. You'll find plenty of ways to get in touch with us through the website. As with all of these kind of briefings, you know, exits are here, here, and here. If you do have to leave early, the recording will be available online afterwards. Please feel free to watch it at your leisure. And also, please feel free to share it on social media or with colleagues within your company if you found it useful. So with that all out the way, we'll sit and stare at the clock for a few more minutes and wait for those people that didn't show up on time. No, I'm joking. Understand everybody has you know, busy lives, and sometimes you can't quite get to these kind of things on time. So let's talk a little bit about the industry, what's been happening in the last few weeks. I'm sure we're all eager to see what the outcome of the sort of Polycom-Mitel merger is going to be. With the Acano acquisition to Cisco, it's a really sort of interesting time to be in the video conferencing industry. Who knows? Things might change again in the future, but for now, what we're seeing is that the consolidation seems to be good for the industry. It's allowing more innovative solutions to be driven, and Starleaf is looking forward to working with a lot of you out there to deliver some of the best video conferencing solutions you've ever seen. So we've still got a couple of minutes to go. I'm starting to see a few people arriving who sent us notes, so we'll give them another 2 or 3 minutes and then we'll get going. Like I say, if anyone has any questions, please feel free, drop them in the chat. I'll try and answer some of them now. I'm getting some questions saying get on with it, but I did promise I'd give people 5 minutes, so we'll hang on for just a couple more minutes. So I have a question here. What do you think about England leaving the Euro Championships? Really, that's kind of painful. No, I'm not going to talk about football. I'm not going to talk about politics. To be honest, I know nothing about either subject. I am going to talk a little bit about video conferencing and the future of the UC industry, but no, I'm sorry, football and politics are off the agenda for today. So, any other questions? No, you guys are just chatting amongst yourselves. Okay, so what's today's agenda really going to be about? Well, we're going to talk a little bit about the history of where the current architecture of video conferencing came from. We're going to talk a little bit about why the current architecture really doesn't suit us moving forward into the future. We're going to talk a little bit about an alternative architecture, in fact, the architecture that Starleaf is pioneering. And we're going to give you some things to think about, that as you move your infrastructure of your UC or video deployment forward, that you really should be considering from an architectural point of view to make sure that you're setting yourself up right for the future. So we're coming into the final minute. Let's see. I think we're still waiting on 1 or 2 more people. So as the screen turns red on the countdown, we'll give them the appropriate time and then we'll get moving. So you all came to this webinar, you were all looking to hopefully to learn something. So please feel free, drop me a note into the chat, tell me what it is that you're looking to get from this webinar, and I'll try and make sure that we address it as we move forward. So as I'm sort of looking at the console now, people are asking what's the difference between the current and the existing architectures. I'm going to cover that in quite some detail in the next few minutes. So I think it's really important, if you're going to be discussing architecture, that you lay out what went before and why it's like the way it is. And if you understand that, it makes it much easier to sort of move forward and understand how the new architecture will be better for everybody. Okay, So we've given everybody the 5 minutes that we promised, so let's make a move and start this webinar. So as I've been saying over the last couple of minutes, this webinar is really about the future of video conferencing architecture. For those of you that don't know me, my name's John Tracy. I've been around this industry for a number of years, and nobody's asked me to leave yet. So I'm going to try and give you a little bit of a history lesson and sort of bring it up to date with why things need to change. So where did the current architecture come from? Well, the reality is it came from the telephony network. The telephony network that was built in the 20s and the 30s that was really nothing more than a simple way of switching one system to another. When you made a telephone call, what actually happened was a physical line came into an exchange like you see in the picture, and then a young lady unplugged the cable and plugged it into somebody else, and the call went down to that thing. So you basically were patching two telephones together with a physical piece of wire. So it really was just a transport for the voice call that happened to run across it. But then in the 70s and coming into the 80s, the world started to go digital. In some countries, a lot faster than others. So for instance, in Germany, they made the decision the whole country is going ISDN for telephony. That was a great thing to do in the 70s, but it's actually been something that's kind of hampered them going forward because the rest of the world didn't do that. So what you actually found was the Germans had a fully digital telephone network and the rest of the world had a fully analog telephone network. Well, I'm sure somebody made a lot of money connecting one to the other. But as the world went digital, it became a transport mechanism for more than just voice. It started to allow other services to be run across the telephone network. And this is where video conferencing came about. So video conferencing used the ISDN network, the digital telephone network, to transport pictures as well as voice. So this allowed an industry to spring up. And we all, for those of us that have been around the industry for a long time, will remember the old PictureTel systems, the old PictureTel Concords, the old Polycom systems, the sort of ViewStation 128s, the ViewStation SPs, or the Tandberg Vision 600s. There were a litany of endpoints that were just popping up. Every few months, another endpoint would appear on the market. And all of these endpoints used that digital telephone network. They all connected across it, sent their data and their voice, and connected to each other. But it still worked in roughly the same way as the old telephone network. Instead of a young lady patching cables from one to the other, what it actually was a digital telephone switch that was connecting one set of lines to another. So the challenge they had there was that the old mechanism of transport became the new mechanism of transport. We didn't actually change the way that we connected these devices together. So what we had was our endpoint. And inside our endpoint, we had a multitude of different protocols. We had video compression algorithms like H.261. We had audio compression algorithms like G711. We then decided, wow, we need better quality video or better quality audio. I know, let's stuff some more protocols into this endpoint. So the endpoints got more and more complex. They needed to be able to encode and decode multiple standards for both audio and video. Layer on top of that, we add in H.221 channel bonding. This was a way of getting more bandwidth by bundling multiple telephone lines together. H.281, far-end camera control, to let you control the camera at the other end. All of this was getting crammed into the endpoints, and the endpoints started to become very complex devices, and very expensive devices at the same time. And as other manufacturers started to move into the space, they started to pick up these standards. But the challenge was, they didn't necessarily implement all the same standards as their competitors. They may have left some out, but they may also have implemented them in a slightly different way. And that meant you started to see incompatibilities creep in. You started to see a problem where manufacturer A and manufacturer B, although they used the same standard, didn't actually work very well together. So then along came the internet and the H.323 protocol. Well, that's great, but unfortunately we were already walking down that path of just using the network as a transport mechanism. And so we continued to do exactly the same thing. We built lots of new endpoints, we crammed lots of protocols into them, even more than we had in our H.320 endpoints. So H.264, G711, G722, G721, AAC-LD, AAC-LC, God, we love acronyms and short codes for things in this industry. But then as the industry grew and more people started to enter the space, all of this extra stuff started to be crammed into the endpoints. And it became a problem because the endpoints have a limited amount of compute capability, they have a limited amount of memory, and they had to run all of this stuff. And they had to run it in a way that they could communicate not only with their own brand of endpoints, but with endpoints from other manufacturers. And this is where the incompatibility in this industry started to come in. And you started to hear the phrase interoperability problems. What you ended up with was a bunch of very sad endpoints. These endpoints, they were designed to work with each other, but the reality was that they didn't. So incompatibility started to hamper growth because manufacturers started to see it as a way of locking customers into their solution. They were saying, well, we won't fix the incompatibilities with other manufacturers. What we'll do is we'll make sure our systems all work together. Then we'll tell people, oh, it's somebody else's problem. If you want to fix it, buy everything from us. So they didn't resolve it. What they actually did was added to the complexity. Because as you get more and more endpoints, the ways that you would dial between them started to change. So they started to add all this infrastructure to make things easy. So we started to add gatekeepers so that we could, instead of dial by IP address, we could dial by an extension number. We started to add firewall traversal servers to get ourselves in and out of the network. We added management servers because this whole thing needed to be managed centrally. We added multi-point conference units so people could join meetings together. And we added gateways to allow you to get in and out, maybe back to the old ISDN network for those that hadn't moved on. And all of this incompatibility just got worse and worse and worse. So people said, well, okay, we'll come up with a simple way. We'll put a bridge in the middle. We'll call it something else. We'll call it a collaboration engine or something like that. And we'll tell people that don't worry about calling from endpoint A to endpoint B or vendor A to vendor B. Just dial into the bridge. Once you're dialed into the bridge, we'll take care of all the incompatibilities for you. We'll become your interop platform. Well, that sounds great on the surface, but you lose the ability to call direct. You lose the ability for me to just dial your number and call you direct. We have to go through the bridge. Imagine if that was how we had to do it with telephones. Imagine if the only way I could call you with a telephone was to send you an Outlook invite, say, can I call you at 2 o'clock? And please could you dial into this bridge, and I'll dial into this bridge, and we'll have a call together. Sounds insane when you talk about it from an audio perspective. So why on earth would we do this for video? So when we look at bridging, it really doesn't scale. Once you want to go beyond a few hundred endpoints or a few thousand endpoints, having a centralized bridging infrastructure really isn't what you need. If you're going to think on a global level, you're going to think thousands, tens of thousands, hundreds of thousands of endpoints. You've got to come up with a better solution. Now you could say, whose responsibility is the incompatibility? If you're Cisco and you have 49% market share, by the way, these figures are based on the latest Wayne House Research spot check numbers. So if you're 49% of the market, you could say, we're compatible with ourselves. It's other people's responsibility to be compatible with ours. The problem with that is that you're not always going to be the big boy on the block. Those of us that have been around the industry for a long time remember a company called PictureTel. PictureTel had 80% market share at one point. And PictureTel decided that with 80% market share, we can just sit back. And along came a company called Polycom who destroyed them within 18 months. In fact, they bought the remnants of the company. So just because you're the big boy on the block doesn't necessarily mean that you can take a view of incompatibility and say it's somebody else's problem. Because there's always somebody bigger coming. Microsoft Skype for Business, if not today, will be the biggest platform for video calling in the world very shortly. But sometimes it's not a technology problem. Actually, sometimes marketing departments do the wrong thing, but with the best intentions. They take a view of, well, if nobody can interoperate with our solution, we're locking our users in and we'll increase our market share. That sounds reasonable, doesn't it? If you're one of the bigger vendors and you lock everybody into your solution, that Interoperability, you don't worry about it because everyone will have to use your platform. They also say, you know, we can deliver a much better quality of service to our users if we just make sure that everybody's on our platform. Interoperability problems will go away because we'll be able to control the whole solution. And they also look at it and say, look, we could become the de facto standard here. If we keep everybody locked in, we make it all work together, and all this incompatibility stuff happens with other vendors, we can make sure that it all sort of works really, really well on our solution, and we will become the standard which everyone will move to. But this is never going to stop. There are so many new things that are on the periphery. H.265, VP9, WebRTC, Google Duo, just a few of them. And if we continue to cram these into our endpoints, that architecture that we talked about earlier is just going to fail. And if it fails, even once, users will lose trust in the technology. The end user will actually revert to older methods. How many times have you heard of people that the video conferencing solution didn't work, so we fell back to audio? Or we got on a plane and flew to the meeting because we didn't trust that the video conferencing solution would work. All of this is down to that architecture that we inherited from the telephony network through the ISDN network into the IP networks without actually rethinking, is this the right way to do it? So I think it's time to draw a line under that old architecture and say, enough. Let's stop doing this because it doesn't scale, it has these massive interoperability problems, and we just need to come up with a better way of doing this. However, we don't have the luxury of throwing all those old endpoints out. It's not like we can build a completely enclosed system and say, look, you know, you people on the other side of the wall, that's your problem. People have spent many, many millions of dollars equipping conference rooms with video conferencing equipment. So whereas we can't necessarily change all of the endpoint devices, we need to look at the network and how the service is delivered as a way of improving upon this issue. Okay, let's consider that old architecture for a moment. I do love this picture because it's not that long ago. We look at this and we think this is a very old picture, but in reality it isn't, and we've moved on from that so quickly. But let's take a look at that old architecture. Remember, it was about connecting your phone via a physical line to a device, an exchange in this case, and everybody came in on a physical line into that exchange. This gave us massive scalability. The devices only needed to be able to talk to the exchange. So they had a physical cable. In the modern world, maybe physical cables have been replaced by cell connections, but you still have a connection to the exchange. And all your device has to be able to do is talk to the exchange. It doesn't have to be able to interoperate with everything else. It just talks to the exchange. And all of the interoperability is done outside of the exchange. It's the exchange to the other exchange is where the interoperability happens. So this means you can build very low-cost devices. We all know telephones don't cost very much. You connect them to an exchange and all of the intelligence sits inside that device rather than in the endpoint itself. So if we swap that architecture and we say, okay, well, what if our endpoints were to just connect to the cloud? They only need to know one protocol, one video protocol, one audio protocol, and maybe one data sharing protocol. But those are the protocols that endpoint is going to use for every single call. All the calls are going to go up to the exchange, which we now call the cloud, and all of the interoperability is going to get taken care of by the cloud. This means that our devices become very, very simple. They don't need to worry about have they had the latest software update to have a support for another protocol that they may or may not use in the future. All of the interoperability happens from the cloud outwards. So your endpoints connect to the cloud, and now any call between any device gets routed by the cloud, transcoded as necessary, and sent on to its destination. Looks familiar, doesn't it? It's the same architecture as the phone system. And we know the phone system scales because there are millions and millions of handsets around the world. And you never have to worry, when I call your phone number, are you on a landline? Are you on a cell phone? Are you on a satellite phone? What manufacturer of phone are you using? Is it an old phone or a new phone? You don't worry about it. You just make a call. So that's the architecture that StarLeaf has been building out over the last few years. As you can see, we've built out a global network of points of presence around the world that allows us to deliver on this massively scalable architecture. We can literally connect hundreds of thousands and millions of endpoints and millions of users globally around the world and all have them make video calls with ultra reliable systems, with ultra reliable delivery of service and compatibility that is unmatched in this industry. So people always say, well, not everybody does cloud. Well, there was an interesting article in Gartner a couple of days ago. It says by 2020, a corporate no cloud policy will be as rare as a no internet policy is today. I don't actually know anybody who has a no internet policy. That seems to be a kind of a strange thing now. So over the next couple of years, as cloud becomes more and more accepted by organizations, their realization that this new architecture gives them so much more that they're not having to give up anything. Their concerns around security are being addressed, and this global platform is there and just makes their lives an awful lot easier. So let's talk about desktop, because this is where the growth is going to come from. There is only so many conference rooms in the world that can have big expensive boardroom tables and large systems in them. However, when we go from hundreds of thousands to millions of users, it's desktop video is where this growth is going to come from. But desktop video has been this ever unfulfilled promise. Every single year that I've been in this industry, I've heard the phrase, this is the year of desktop, this is the year it's going to explode. And that started way back in 2000 with the Polycom Via Video. This was a little hardware accelerated webcam. This is the year, this is the device that's going to drive millions of people into video calls from their desktop. Well, that never happened. Then in 2007, along came Tandberg Movi, or Movie, whichever you want to pronounce it. Everyone said that this is the first real corporate solution. This is the first solution that's designed for businesses to get thousands of users on. Never happened. Along to 2009, Tandberg decided that the answer was the E20, which was actually a very beautiful little desktop phone with a small screen on it and a camera that allowed you to use it as a telephone and as a video system on your desktop. Again, didn't take off. Limited interoperability, and after 3 years was killed off. Then Lifesize launched its Lifesize Connections, its first attempt at a cloud platform, but poor interoperability, instability, limited deployment around the world of points of presence. They finally killed that product off and decided to go rebuild it from the ground up. So we still haven't reached the year of desktop video, but we're starting to see now with Microsoft Skype for Business that and a few other solutions that are available on the market, we're starting to see the growth in desktop with these tens to hundreds to thousands to millions of users coming online. Why don't we just deploy enterprise grade servers, put them in data centers, call it a cloud? Well, if you just take the file traversal aspect, it's a small part of the service, but actually a critical part of it. If you just look at the leading manufacturers of enterprise grade servers and look at the capacities that each individual server can actually maintain. So the highest one there, the Cisco VCS CE1000, will allow 500 traversal calls. So to get to those scale of millions of users, you need something much, much bigger than that. You can't just rack up thousands and thousands of these servers and call it a service. It was never designed to support the level of users that we're going to need for this kind of revolution. So what happens when your vendor tells you, well, I'm sorry, but we don't support your particular endpoints anymore, or the feature you're asking for is not available in your endpoint, you need to go and buy some new endpoints, or sorry, that piece of hardware is just too old. And we hear this all the time when customers are saying, we need to be able to interoperate with Skype for Business. Well, any endpoint connected to the StarLeaf cloud automatically inherits the ability to make Skype for Business calls. Because of that architecture, the Skype for Business interoperability is done by the cloud. So it doesn't actually matter what your endpoint is that's connected. It could be an old Sony PCS system, a 15-year-old video conferencing system, and that system then can make Skype for Business calls. Some vendors are also using the move to cloud to say to their customers, I'm sorry, but the endpoints you've got are too old to use on cloud. Well, all of those endpoints that have been kind of left out by their existing vendors can all connect to the StarLeaf cloud and can all be an active participant in everything going forward. Because of that architecture, all of the new interoperability being done in the cloud, so long as those endpoints can connect to the cloud, they can take advantage of all the features. And by taking advantage of all those features, they gain all the interoperability. So you might have an endpoint that's only capable of H.264 baseline protocol, but you need to be able to do a call with an H.264 SVC-based endpoint. Well, the cloud can take care of all of that for you. It can make sure that no matter who you're trying to call, the call goes through. And just because your vendor tells you your endpoint's of end of life, doesn't mean the endpoint is no longer of any use. Just think about it. Your users may have been using that device for 3, 5, 7, 10 years. They may be very comfortable with how to dial a call. Just because your vendor tells you, well, it's end of life, you need to throw it away and buy something new that you're going to have to sit and retrain all your users on, doesn't mean that that endpoint is no longer of any use. By connecting it to the cloud, you can continue to use the same user interface that you've always used and your users are comfortable with, but you can inherit all of the new features that the cloud brings. So, what does the cloud architecture, this new architecture, bring you? Well, the first thing is lower cost of networking. All of those boxes that you've got sitting in your data center gathering dust that are making 1 or 2 calls a month maybe, but are costing you power, they're costing you cooling, they're costing you networking, all of those things, you can decommission them, connect your endpoints directly to the cloud, and you start to make some instant savings. As I said earlier, you can continue to use your existing endpoints. We have some customers recently who've connected old Lifesize endpoints that are no longer supported on Lifesize's cloud, but work perfectly fine when connected to the StarLeaf cloud. They're able to make calls and interoperate with things like Skype for Business. They're able to get their directory from the cloud. So it means that those endpoints that people did spend an awful lot of money on still have a legitimate use going forward. And ultimately, by moving to the cloud, you are able to do so much more with so much less. You don't have to have technicians who are dedicated to setting up calls for everybody. The number of customers we've spoke to who they say, oh, well, we're not sure about video. So what we do is we have a technician go down to the room 20 minutes before the call. He dials the call and gets it all set up and makes sure the microphones are working. And then when our executives go in, he goes and sits outside and waits till the meeting's concluded, just in case they have a problem. That sounds like a crazy way to do business to me. But it means that all of those engineers who are sitting outside conference rooms because people don't know how to use the complex systems that they have can get on and do other things. They can go and actually do some real work rather than sitting outside a conference room because a senior executive doesn't trust the system that he's using. So the reality is, with this new architecture, we have a very simple message that we can give to customers. We say you can call anyone on any device at any time. Now, that shouldn't be a marketing message because that's the reality of the telephone network. I can call any person on any device at any time. So you should ask yourself, well, why doesn't the same apply to video? Well, with StarLeaf Cloud it does. It allows you to make those calls. You don't have to worry about who are you calling, what device are they on, can I call them, do I have to go through a bridge or any of that other nonsense. Call anyone on any device at any time. Okay. So we've sort of come to the end of the presentation. I'm looking down at my console here and we've got quite a few questions. Just for time, I think we've probably got time to go through 3 or 4. So let me get ask Alice to just push a couple of questions up onto my screen so I can actually read them with my glasses on, and we'll get through as many as we can in the time we've got left. Okay, question 1. What competes with the StarLeaf Cloud? Oh, straight in at the deep end. Okay. As the old saying goes, often compared, never equaled. So the StarLeaf Cloud encompasses so many different things that other companies do small pieces of. So for instance, BlueJeans and Zoom do conferencing. They do multi-party conferencing, but you have to get to their conference. They don't take care of how does your endpoint connect out of your network to get onto the internet to connect to their conference. Lifesize does registration, so it solves that firewall traversal piece, but it only does it for a subset of its own endpoints. Cisco and Polycom, they have their own systems, like Polycom's cloud offering and Cisco Spark. but they're really designed for users of their own endpoints. As I said earlier, it's about locking those users into their solution. StarLeaf's the only cloud that offers a full suite of services, from endpoint registration through connection, transcoding and routing, conferencing, recording, all of this wrapped around an interoperability platform. So who competes with StarLeaf Cloud? Very few people. Okay, question 2. Now, one thing, if you've seen my previous webinars, people got a little bit embarrassed when I called them out by name for asking questions. So you'll notice this time I'm not actually telling you who's asking the question. I'm just reading the questions off the screen. In fact, I can't even see who's asked these questions. So, how does this differ from other clouds like Cisco and Lifesize? Well, as I said before, they're really focused on their own hardware. Their solutions are about getting you to buy into their ecosystem of hardware endpoints and software codecs, and delivered through a cloud-based service which they own and operate. By keeping you locked into one solution, they're using the old excuse that I talked about earlier, about making sure that you use their solution, because if you use just their solution, you won't get any interoperability problems and everyone will be happy. Well, the reality is things change pretty quickly in business today. You don't know that through some merger and acquisition that you're not going to have another company come together with you, and they may use something completely different. So then you have to make a decision. Do we throw this away, or do we migrate this to this? Why not have a platform where you can just say, look, it doesn't matter what you use. You can come with any type of video endpoint, you can connect it to the service, and we can all interoperate together. Okay, question 3. Is it possible to just have conferencing and use my current systems? So by conferencing, I assume you're talking about multi-party conferencing here. The answer is absolutely yes, but conferencing is only part of the solution. As I said before, with BlueJeans and Zoom and others that provide just a conferencing platform, they don't solve the problem of how do you connect out of your network in a secure method to get to that conference. How are you going to get through that firewall? How are you going to make sure that once you're through the firewall that you're transcoded into the right format before you can get into the conference? But more importantly, what about point-to-point calling? If you're just using a conferencing service and you're using it as your main method of interoperating with other endpoints, you're missing out on point-to-point calling. Now, our data suggests that about 80% of all calls that go through our cloud are point-to-point. So you're missing out on the 80% of all the calls that happen by just using a conferencing service. But it may be the way your business operates, the way that your workflow happens, that conferencing is the way that you want to do that. So absolutely, StarLeaf can deliver you a conferencing platform. Okay, we got time for one more. Can you connect to Google Hangouts? That's a real easy one to finish. The answer is no, I'm afraid. Google Hangouts is a closed system. We do hope at one day that Google might open it up and allow others to interoperate with it. But as it is today, we can actually give you the same experience that you would get in Google Hangouts by using Google's WebRTC platform. So you'll be able to connect to multi-party meetings through a web browser and participate in those meetings just the same way that you do through Google Hangouts. But you'll also be able to bring in all of those conference rooms, maybe Skype for Business users, maybe people on laptops and tablets, all of those into the conference in exactly the same way as you can on Google Hangouts. You'll just be able to do it with equipment from other vendors. So that's really all we got time for today. I hope you found this useful. I hope you got your questions answered. If you didn't, as I said, our fantastic marketing team will reach out to you in the next couple of days and give you answers to those questions. If you want more information, please go to our website, www.starleaf.com. Take a look. There's plenty of ways that you can reach out to us on there, or find us on LinkedIn or Facebook or Twitter or any of the social media channels, and we'll be more than happy to answer your question. Thank you very much for your time today. I hope you found it useful, and I'll see you next time.